In our last last lesson of Unit 10, 10.7, we're going to talk about surface area of a sphere and hemisphere, maybe. The formula to find the surface area of a sphere is memorization, pretty much. It's 4 times pi times the radius squared. Don't forget that area is in square units, so take your units and square it, whatever that might be, because again, we're talking about area, not volume right now. So down below, what I see is I see a sphere that has a radius that is 7. So I'm going to take that 7, and basically all I do is I plug it in wherever I see the r, and I'm finished. So I take 4 times pi times the radius, which is 7, squared, multiply it all out, and in the end, I find out that I get 615.75. And since our units were in centimeters, I would write down centimeters squared. Notice again, the number's not being squared, the label's being squared. So 4 times pi times the radius squared. Another formula we memorize. In the second slide here, we're going to do something a little more complicated. So we're going to use our knowledge of surface area for other solutions. So we're going to find the surface area of a sphere, but they're going to give us some other information first. So the information that they give us is that the volume is 12,348. So I'm going to use that information. Okay, so here's what I do with that. I know the volume formula, so I say 12,348, which is my volume of a sphere, is the same thing as 4/3 times pi times my radius cubed. This is the formula that we used before. In case you don't recall, it was volume of a sphere equals 4/3 times pi times the radius cubed. And all we've done really is we've talked about how this 12,000 thing is the volume. Now what I see is I have a variable called r that's being cubed, and I need to get rid of it. So the way I get rid of it, or I should say I need to get it alone, is that I divide both sides by the 4/3 times pi. Don't forget to put that into a parentheses when you use your calculator, and I would like you to try that now as I'm doing this. When you get done, what you should see is that your radius cubed on the right-hand side is now by itself because the things on the top and the things on the bottom divided out and canceled. And now we have radius cubed equals, and when I divide that stuff, what I find out, as I use my calculator here, so give me one moment, I have 12,348 divided by parentheses, 4 divided by 3 times pi, and I get 2,947.87. Now this number is not what your radius is, it's what your radius cubed is. So in order to get rid of that, you have to take the cube root of both sides to undo the cubing. The way that you do this on your calculator is you say that r will be equal to, and you take that 2,947.87 and you raise it with the caret button to the parentheses 1/3. That's the same thing as cube rooting something. So I do that on my calculator and raise it to the 1/3 power, and what I see as a result is that my radius turns out to be 14.34, and in this case we are in, I believe, centimeters? No, meters, pardon me. And that's my radius. Now, we haven't actually done the problem because they wanted us to find the surface area. But now, since I know what my radius is, I can go back to my knowledge of surface area, and I know that surface area, we just learned of a sphere, is 4 times pi times my radius squared. So in this case, that's 4 times pi times 14.34 squared. And when I finish, I see my final answer is 2,583.54. And since I'm in area, I have meters squared. So my surface area, I can get to, but they gave me the volume to begin with. The reason that they gave me that volume to begin with is so that I could find the radius. I needed the radius so that I could use that in my surface area formula. Big idea here is putting multiple concepts together to find a solution in a word problem.